Welcome to Secrets of Si8000m. This is one of a series of presentations which will help you get the most from your Si8000. In this brief presentation, I'll demonstrate two ways of exploring the process window of your design. First, we'll show single process window calculations, and you click the process window icon to start the process window dialog. In the following screen, I'll show you a range of scenarios run from the software itself. You'll notice here in the center of the toolbar is the process window icon. So let's run the software and see what happens when we explore the process window. First, I'll set the impedance to a convenient 50 ohms. I'll just goal seek the width and then we'll select the process window. The process window dialog pops up and the chevron signal here shows you how to link in the parameters from the lossless tab in the field solver. Setting the tolerance to 10%, and the drop down allows you to show how much process window there is for a range of parameters. Here we've looked to see how much height variation you can cope with whilst maintaining an impedance within 50 plus or minus 5 ohms. The same for the width. Again, 50 plus or minus 5 ohms, and you can see from 19 down to 13 mils. The next example isn't going to work completely. You can see we can't find a goal seek here, and what we've done is we've varied the trace thickness, and it's a really exaggerated example. The thickness goes from 8 mils to 1 to 0. Finally, we'll set back again and look at the width. You can see that the width varies, and we can close the process window, and it fully allows you a method to explore how much space you've got for your design. The next scenario is a little bit more complex. We can use the charting and sensitivity analysis capability. Again, you select the process window from in the chart and then use the minimum maximum checkbox to chart the effects of varying parameters within defined limits. So this example, we're going to hold the differential impedance constant at 75 ohms, vary the trace width, but also look at how much trace width variation we can cope with and still hold the impedance within specification. In this case, we're going to look specifically at varying width 1 while we sweep the height and look at the process window where the impedance is between 75 ohms plus or minus 5 ohms. Again, we'll simulate running the software. So first I'm going to close the single process window dialog and then move to the bottom of the application and select sensitivity analysis. Turn on the checkbox for process window and manually edit the minimum and maximum impedance. So there's a nominal 75, and we're going to run the process window calculation. You can see here we've got three lines, a constant 70 ohm, a constant 75 ohm and a constant 80 ohm line. By selecting any point on the line, you can pick the impedance and you can see read off the height and the width at a particular point on the line. It's interesting to note in this example that as the height increases, you get more process window in terms of width. Looking at that the other way, the more you reduce the height, the tighter your etch needs to be to maintain the specified impedance. We can maximize the graph to print out into other applications. I'll move on to the next slide, and here you can see a graph of the process window for a 75 ohm line, 70 and 80 ohms, while we sweep the height and the width. So, very brief presentation. Thank you for looking, and I hope that's been useful for you and helped you explore the maximum capability of your Si8000. If you'd like a web-based presentation or an evaluation, please do contact your local Polar office, and the details are shown here.